Hello, welcome to Maths with EJD. Still on statistics, this video is about measures of central tendency or location. So there are a couple of measures in statistics like that. So, of course, the first one we're looking at today is measures of what we call measures of location or central tendency. Afterwards, we have measures of dispersion, or you can call them measures of variability, measures of variability. Then we have other measures like measures of course, measures of location are things like mean, median, mode, that central tendency. Measures of dispersion will be things like interquartile range, uh, standard deviation, variance, and all of that. And you also have measures of shape. Okay, measures of shape, things like skewness and kurtosis. And then there's measure of position, when you talk about percentiles, deciles, and quartiles. So those are the measures we have in statistics, and we're taking this one after the other. So for today, the focus is on measures of location or measures of central tendency, like that. So that's the essence of this. You should understand that central tendency or location, if you like, refers refers to a central point, refers to a central point or typical value, typical value for a set of data. So in simpler terms, right, it's more like representing the whole data you have with just a single value. So those are measures of central tendency. So one value to represent the whole data, no matter how big the data is. So that's measure of central tendency. So, and these are like what are the most important measures, the most common measures I believe that most people know in statistics. So the three of them, main measures, the three main measures of central tendency, of central tendency, or measures of location are mean, median, and mode. Mean, median, and mode. Okay, so the three measures. So that's what we have to look at here. So let's explore these concepts. These concepts with examples. There are different types of data, right? So we can talk about groups and ungrouped data. So let's explore this concept with examples for both ungrouped and grouped data. Ungrouped and grouped data. So ungrouped data is data just freely there, whereas group data will be data uh clearly arranged in a table with intervals and things like that. So let's start with ungrouped data. Ungrouped data. So, and the first thing we are looking at for ungrouped data would be mean, or what you can call arithmetic mean. Interestingly, there are all kinds of mean, but in this case, we are focused on arithmetic mean actually. So the mean actually is the sum of all values divided by the number of values divided by the number of values. It is also known as average, basically. So the formula is the summation of all the variable points, all the data points you have divided by the number of the data, where X is each value, in the data set. Don't forget, this is talking about ungrouped data now. We are particularly talking about ungrouped data. As data given in discrete form. Then you have n is the number of values. N is the number of values. Okay. So that is mean for this. For example, say, okay, consider the data. Consider the data 5, 5, 8, 7, 10, and 4. This is ungrouped data like that, and it is discrete. So what do? The mean, of course, is the summation of each number divided by the number of numbers, so to speak. So that means you have 5 plus 8 plus 7 plus 10 plus 4 over 5 of them. 1, 2, 3, 4, 5. Okay. So that is 5 plus 8, 13, 13 plus 7, 20, 20 plus 10 is 30 plus 4, 34 divided by 5. So, and that just give you 6.8. So the mean here is 6.8. Okay. That is 6.8. How about the median? How do you calculate median for this? So we've done mean right there. Let's talk about median now. What does the median look like for ungrouped data? So actually the median is the middle value when data points are arranged in ascending or descending order. So that simply means that if you want to get if you want to get median, you have to arrange the data you have in ascending or descending order. Okay. So if the number of values is even, okay, it is the average of the two middle values. Okay. Of course, if it is odd, there's clearly a number in the center. So what are the steps now? Steps to find median. Okay. Steps to find median. Number 1, arrange the data in order. Arrange the data in order. Okay. 2, if n is odd, that's the number of data you have, is odd, the middle value is the median, just like I said, not quite long. And then the third step, if n is even, that's the number of data you have is even, the median is the mean. The median is the mean of the two middle values. Okay. So let's take an example. So working with the same data we had before, right? We have 5, 8, 7, 10, and 4. So step 1, order the data. So the ordered data, like we already said, you can order in ascending or descending. So let's do ascending. So we have 4, 5, 7, 8, and 10. Okay. So in this case now you have 5 values now. So that means that you have 4, 5. That's 1, 1, 2 from the front, 1, 2 from the back. And then in the center you have 7. So this is clearly the median. Okay. That will be the median because 7 is in the center. If you also arrange it in descending order from 10, 8, 7, 5, and 4, it is still the median, right? So, and so therefore, the middle value is 7. So the median is 7. The median is 7. Okay, I think okay, I said I was going to do all this. I mean, I think it's important to do an example with even numbered data. So let's say you have another data. Let me just add something to that. Let's say you have 5, 8, 7, 10. If you have 5, okay, let's say original data, right, is 5, 8, 7, 10, 4. 5, 8, 7, 10, 4. And then maybe you add something, let's say 6 now. So that's the raw data. Then the ordered data would be 4, 5, 6, 7, 8, and 10. So here, if you can divide into 2 equal parts from what you have. So you have there are 6, right? So you have 1, 2, 3, 1, 2, 3. Okay. So the next numbers to the right and left of the bars will be actually in the center, right? So in this case, your median would simply be, your median is going to be 6 plus 7 divided by 2. That's 13 over 2, which is 6.5. That's the median in this case. So order the data. The middle number for odd is the median, but the two middle numbers for even divided by their sum divided by 2 will give you the median. Okay, so that's about median. Let's talk about mode. Let's talk about mode. So mean, median, and mode are the 3 measures of central tendency or location. So let's talk about mode. So for mode, right, probably this has the simplest definition. The mode is the value. The mode is the value that appears most frequently in the data. Most frequently in the data. That is what the mode is. So, for example, now you want to find the mode of this data. Data is 5, 8, 7, 10, 4, 7, and 10. Okay. Now, here you see so if you look at their frequency, so we can quickly do something. So you have 5 appears 1 time. So this is the number, and this is the frequency. Okay. So 5 appears 1 time. Okay, we can even start with 4. Let's start with the smallest. So the smallest number is 4. It appears 1 time. Then 5 appears 1 time also. Then after that, you have 7, which appears 2 times. And after 7, you have 8, which appears 1 time. And lastly, you have 10, I believe, which appears 2 times. So you have 1, 2, 3, 4, 5, 6, 7. So yeah, so everything is like this. So if you look at the most frequent are the ones that appear twice each, right? So in that case now, since there's no one that has the highest frequency, so we can say that this actually is bimodal, okay? So we say here both 7 and 10 appear twice. So the modes, are 7 and 10. Okay. So you say this is a bimodal distribution. It has 2 modes, bimodal distribution. If it has 3 modes, that will be a trimodal distribution. If it had 1, it would be unimodal. So for instance, if we had just 10 one time, so the mode would be 7 with with a frequency of 2. Okay. So that's that about ungrouped data, right? Ungrouped data. Now, how do you calculate all this for grouped data? Things become a bit trickier in this case, and then you're going to have to encounter some formulas. So let's see how this works. So let's talk about grouped data. Data grouped. They have intervals and all that. So we can say that grouped data refers to data presented in intervals, data presented in intervals, or if you like, classes, rather than individual values. For this, we use class intervals and frequencies. Class intervals and frequencies. Okay. Now, in this case, can we talk about the mean? What does the mean look like here for grouped data? So we can say that for grouped data, the mean is calculated using the midpoints of class intervals. I'm going to explain the idea of midpoints in a moment. So using the midpoints of class intervals. So, and the formula is something like this. The formula is mean equals the summation of the frequencies multiplied by the mid values divided by the summation of all the frequencies. That means the total number of what you have. Okay. That'll be explained with an example to drive the point home. So Fi, right, is the frequency of the ith class, That means if you have the first class, which is from 0 to 9, and you have 10 people in that category or 10 things in that category, so the frequency will be 10. Okay. Then you have Mi. Mi is the midpoint. Mi is actually the midpoint of the ith class. The midpoint of the ith class. Okay, let's take an example so this can be well taken care of. So example, consider the following grouped data. So here you have class interval, and then you have the frequency. Okay. So first class is 0 to 10. You have 5 things in that group, or 5 items in that group. You have 10 to 20, 10 items. You have 20 to 30. So the class intervals. Now that's 15 there. And then you have 30 to 40, and you have 20 items in that class. Okay. So to calculate the mean in this case, right? To calculate the mean, in this case, what do? Yeah, it takes some steps. Step 1 is find the midpoints of each class. Find the midpoints of each class. Because you don't always have to do this separately the way I'm going to do it. So you can see the first class is 0 to 10. So the midpoint of that class would be M1, which is 0 plus 10 divided by 2. So 0 to 10, that's 0 plus 10 divided by 2. That's 10 over 2, which is 5. Then the second midpoint, M2, that's for 10 to 20, right? That's 10 plus 20 divided by 2. That's 30 over 2, and that is 15. Okay. Then the third midpoint is actually 20 plus 30 divided by 2. That is 50 over 2. That is 25. Okay. Then the third midpoint is 30 plus 40 Oh, is it the third? Now this is the third and this is the fourth. So that's 30 plus 40 divided by 2, which is 70 divided by 2, and that is 35. Now, you can see already that if you're in an exam situation and you have to hurry up, you can already, by the time you do the first two, you can always know the rest, because the interval is going to be, it is more like a kind of ratio interval. So the interval is going to be consistent. So once you get 5 and 15, just keep adding 10 to get the other. So 5 plus 10, 15, 15 plus 10, 25, 25 plus 10, 35, except if you're required to show all the steps. But most times you're just required to show your table and the values and things like that. Okay. So that's the first step you do. You find the midpoints of each class. And then step two, in step two, you multiply midpoints, by corresponding frequencies, by corresponding frequencies. Okay. So, okay. I mean, I'll just make that statement for now, and I'll show all the workings in the table. Okay. Well, okay. Okay, I'll just do this now, and then I'll show the table thing. So now it's just for explanation. So multiply midpoint by corresponding frequencies. So you see the so corresponding to this midpoint now, I mean to the so this one now, the midpoint would be 5. The midpoint here is 15. The midpoint here is 25. And the midpoint here is 35, right? So the next thing you have to do is you have to multiply the pairs like that. Okay. So that's the next step. Multiply midpoint by corresponding frequencies. So in that case now, that's actually like, okay, that is actually FI-MI. Okay. So that simply means that F1, M1, that's the frequency for the first one, and the midpoint is actually 5. You get 25. Then F2, M2, that is 10. The second frequency is 10 multiplied by 15. Okay, 10 by 15, that is 150. And then you have the third one, F3, M3, F3, M3, that is 15 by 25, 15 by 25, and that is 375. Okay, then what's the next thing? F4, M4. F4, M4 is F4, M4 is 20 by 35. 20 multiplied by 35, 20 multiplied by 35. That is 700. Okay, that's the third step. Then step three would be to find the sum of frequencies, the sum of frequencies Fi and products FI-MI. So you find those sums. So the first one is sum of all the frequencies would be, all the frequencies we have is 5, 10, 15, 20, right? 5, 10, 15, 20. So you have 5 plus 10 plus 15 plus 20. And all of that is 5 plus 10, 15, 15 plus 15, 30 plus 20. That is 50. Then you have summation of FI-MI. In an exam situation, this is not the best way to go. I'm just explaining. I'm going to explain how you should really behave in the exam. So summation of FI-MI would be FI-MI, the values you got, 25, 150, 375, 700. You add up all those to 25 plus 150 plus 375 plus 700, and that is 1,250. Okay. So with that now, you can go to step 4, which is the final step where you calculate the mean. So step 4, you have to calculate the mean. Calculate the mean. So here, the mean is simply summation of FI-MI divided by summation of FI. Sometimes it may be something like, you can just represent the summation of FX over summation of F. It all depends on how you want to represent it. Okay. So now that would be 1,250 divided by 50. And you see that your mean, sometimes written as X bar, is 25. So the mean is 25 in that case. So you can actually find the mean that way. Okay, so I've been talking a lot about how to do this in the exam situation instead of having to go this way. So you just need draw a correct table and be fine. So in that case, all you just need to do is have your class interval 0 to 10, the first, the second, 10 to 20, the third, 30 to 4, 20 to 30, 20 to 30, and lastly, you have 30 to 40. So you have that, and you have frequency. Those are the first two things you have given. You have 5, you have 10, you have 15, and you have 20. These were given from the very beginning. So the next thing you need is the midpoints, right? So you need the midpoints. So these are your FIs, these are your MIs. So the midpoint, like you said, 0 plus 10 is 10 divided by 2, that's 5. 0 plus 10, 10 divided by 2, 5. Then 10 plus 20, 30 divided by 2, 15. So once you see that difference is 10, so just keep adding 10. So this will be 25. This will be 35. Okay. So what else do you need? I think, yeah, the next thing you would need is FI, MI, multiplying the two together. Okay. That's about the other thing you would need. So here you have your FIMI 5 times 5, 25, 10 times 15, 150, 15 times 25 is 375, and 20 times 35 is 700. So it's better to have this kind of table now. So from here, you can then do your summation of FI, which is simply 50, and then you do your summation of FI, MI, or if it is FX you're using, so that'll be 1,250. Then you can now do your X bar, which is the mean, which is summation of FI, MI over summation of FI, which is 1,250 divided by 50. So the table style is actually the best. So you don't have to I mean, if you have all the time, you may want to show all the workings. But if you don't have all the time, just do your table and do your computation, write on the table, extract the values you need, and go on with your life. So that's about mean, right, for grouped data. Now let's talk about median for grouped data. Median for grouped data. Okay. So now, okay, I guess I want to change the color of this point. So let's talk about median. Median. Talking about grouped data now. So of course, for grouped data, right? For grouped data, the median is not as simple as what you got before, just arrange and pick the middle value, So the median is found. The median is found. You have to use the formula in this case. Using the formula, median is equal to L plus N over 2 minus F divided by FM multiplied by H. Now it looks somehow, but you just need to understand the formula and interpret as appropriate. So what do these terms mean? So where L is the lower boundary, L is the lower boundary of the median class. Okay, so it means you have to identify the median class and now get the lower boundary of that median class. I'm going to explain all that with the data we've been using. So, and then the next thing is that N, so this N now, L is the lower boundary of the median class. N is the total number of frequencies. N is the total number of frequencies. That is what we called summation Fi in the previous situation. So it's the total number of frequencies. Then the next thing, you have L, you have M, N. Now let's talk about F. This is like big F. Looks like I'm not representing the F's properly. Okay, so this is big F, and this is small f, something like that. So the big F is actually the cumulative frequency. Cumulative, the idea of cumulative means summing things up, right? F is a frequency, cumulative frequency before the median class, before the median class. Okay. And lastly, okay, not lastly now, we still have FM and H. So next is small fm is the frequency. It is the frequency of the median class, the frequency of the median class. And lastly, H is the class width. H is the class width. So you see, we've been talking about the median class. So it means the first thing you have to do is to identify the median class. And then H is the class width, which will always be consistent. That's like the difference between the smallest value and the biggest value. Or yeah, something like that. Okay. So let's use the data we've had before. So where we had CI and frequency as follows. So 0 to 10, 5, 10 to 20, 10, 20 to 30, 15, and 30 to 40 is 20. So like this. So like this. Now, we've been talking about, okay, first, let's talk about the number one, the total frequency. What is the total frequency? Total frequency N is 50, right? That's N here is summation F, which is 50 as we know. 5 plus 10, 15, 15 plus 15, 30, 30 plus 20, that's 50. So number two, we need this N over 2. So we need half of that, right? So the next step, we have half of N is equal to 50 over 2, which is 25. That's done. Now, when you talk about the cumulative frequencies, I think it's always best to use the table. Let me carve that. So the cumulative frequencies will just be, so for the beginning, from 0 to 10, that's 5. For 10 to 20, cumulative frequency 5 plus 10, that's 15. So it's like you're adding things of 5 plus 10. Now 15 plus 15, that's 30. And 30 plus 20, that gives you 50. So that's how cumulative goes. Okay. So the cumulative frequencies are 5, 15, 30, and 50. Like that. Okay. So another thing you want to do is you want to get the median class. The median class, right? Because since you have 50 items, the median class will be one that is at halfway 50. So let me put it this way: to identify the median class, or I think it's better to say the median class is associated with N over 2, which is 25. So wherever you have the 25th item is your median class. So if you see, this is 5 plus 15, 5 plus 10, 15, 15 plus 15, 30. So if you look at this 30 now, so this is 15. So it means the 25th. So after 15 now, this is 16, 17, 18, 19, 20 up to 30. So the 25th item falls in this class. So that is why this will be your median class. Okay. That will be the median class, which is really pivotal in the whole calculation you'll be doing. So we can say, the median class is 20 to 30 because the 25th value, that is based on N over 2 now. The 25th value lies in this interval. That's why 20 to 30 is the median class. So now that you have the median class, then it means that you can now get your L. So that means L is 20. The median class is 20 to 30. And don't forget, L itself is supposed to be the lower boundary of the median class. So, and when we talk about boundary, this is lower boundary, this is upper boundary, lower boundary, upper boundary, lower boundary, upper boundary, lower boundary, upper boundary. So for the median class, the lower boundary is 20. So L is 20. That means the lower boundary of the median class, the lower boundary of the median class. Median class. So that goes. Then next, we need the big F. The big F is the cumulative frequency before the median class. Now look at the median class. It is 20 to 30. What is the cumulative frequency before you get there? So the cumulative frequency just before the median class is actually this 15. So that's 15 before you get there. So we can say that F is 15 because it is the cumulative frequency before the median class. Okay. Then we also need FM, small fm now. So it's actually 15 too because that is supposed to be the frequency of the median class. Small fm is the frequency of the median class. So the median class is 20 to 30. So its own frequency is 15. So interestingly, it's just like before. So FM is 15 as frequency of the median class, Okay. And lastly, you need H. H is actually the class interval or the class width, and that is 10. That is the class width. Why is it 10 though? In each class, you have the difference between the smallest value and the biggest value. So that's 10 minus 20. 10 minus 0 is 10. 20 minus 10 is 10. 30 minus 20 is 10. 40 minus 30 is also 10. Okay. So that's why the H is actually the class is 10, and that is the class width. All right. So now that you have everything in place, you can now plug all those values. So now plug the values into the formula. Plug the values into the formula. That means you have median. Median, of course, again, is L plus N over 2 minus big F, all divided by FM multiplied by H, which is the class width. So that means your median is 20. That is the lower boundary of the median class, plus N over 2, which is 25. That is total frequency divided by 2, minus cumulative frequency before median class, that's 15. Cumulative frequency before the median class, that's 15. Interestingly, the frequency of the median class is also 15, as you have seen, then multiplied by 10. So we can compute this now. So that's 20 plus 25 minus 15 is 10 divided by 15, multiplied by 10, like this. Okay. So that means we have 20 plus 100. You have to do multiplication first, divided by 15. So that is 100 divided by 15 is 6.67. So that means the median value is actually 26.67. So that's the median for this group data. So it's not as straightforward as before. So, and that makes sense, right? This is 26.67. And you can see 26.67 lies within 20 and 30. So that is the median. So it may look somehow, but you just need to master the formula and the terms of the formula, and everything will be nice. Okay. All right. Let's move on to mode for grouped data now. Let's talk about mode for grouped data. How does that work? Again, we have another formula. So we say for grouped data, the mode The mode can be found using the formula. Using the formula, which is mode equals L plus you now have Fm minus F1 all over Fm minus F1 plus Fm minus F2, like this. All this now multiplied by H. Okay, so now we need to know what each of the terms actually mean. So where now L is the lower boundary, of the modal class. Lower boundary of the modal class. You know, the other time we're talking about the median class. The modal class will be the class with the highest frequency. So that's easier to identify. So the lower boundary of the modal class, really important. You know, we're talking about mode, so it has to be modal class. Then next you have FM, you know. FM is the frequency of the modal class, is the frequency of the modal class. Okay. Then next you have F1. F1 is the frequency of the class preceding the modal class. The class preceding the modal class. And then you need F2 also, which is the frequency. F2 is the frequency of the class succeeding the modal class. As a class after the modal class. Succeeding the modal class. And H, as usual, is the class width. H is the class width. So imagine what we had before. Imagine the example we had previously. So you have the class interval, you have the frequency. Let me just say F, have a frequency. So, and then you have 0 to 10, the frequency is 5 again. You have 10 to 20, the frequency is 10. You have 20 to 30, the frequency is 15. You have 30 to 40, the frequency is 20. Okay. So as that goes, you need to unpack the formula. Of course, it's clear. The modal class is clear here. The class with the highest, oh no, the modal class is the class with the highest frequency. And the highest frequency is 20. So the class with that frequency is 30 to 40. So you can simply say that here, the modal class is 30 to 40 since it has the highest frequency. Okay. And then we need the other items. We need L. L is 30 because 30 is the lower boundary of the modal class. This is the modal class. So the lower boundary is the lower boundary. So lower boundary of the modal class. Then you need FM, right? Which is the frequency of the modal class. And that's simply 20. So that's this 20. So it is FM. It is the frequency of the modal class. 30 is the lower boundary, don't forget. 20 is the frequency of the modal class. And then we need, okay, we can say frequency of the modal class, frequency of the modal class. Okay. Then we need F1. F1 is 15. Okay. So F1 is the preceding frequency. Okay. The preceding frequency before the modal class is 15. So this is F1. Okay. So F1 is 15. That's preceding frequency. Now we need F2, which is the succeeding frequency. That to be 0. Because after the modal class, there's no other class. So we can say that, okay, imagine there's no class here, right? So the class doesn't exist. So F2 is actually 0 since there's no class after that. But if this were to be the modal class, so F1 would be 5 and F2 will be 15. Okay. So here there's no class after the modal class. So F2 is 0. So uh in that case, we are saying that succeeding frequency. So because assuming no class beyond 30 to 40, beyond 30 to 40. Okay. And of course, H is 10. That's class width, the difference between the highest value in the class and the lowest value. So now let's compute. Now plug the values, into the formula, So we have mode now to be equal to, okay, L plus FM minus F1, I believe. FM minus F1, yeah. So you have FM minus F1 divided by FM minus F1 plus FM minus F2, all that multiplied by H, so that mode now is equal to the modal class is 30 to 40. So the lower boundary is 30 plus FM, the frequency of the modal class, that is 20 minus the frequency before, that's 15, all over that same 20 minus 15 plus FM 20 minus 0, that's the frequency after, all this multiplied by 10. And then we can tidy all of that up. So this is 30 plus 20 minus 15 is 5 divided by 5 plus 20 multiplied by 10. So you have 30 plus 5 over 25 times 10 over 1. Okay. So that's like 30 plus 50 over 25. 50 over 25. And that is simply the mode, that is actually 30 plus 2. So the mode is 32. So for that group data, the mode is 32. Of course, the mode would automatically fall into the modal class. The modal class is 30 to 40. So based on the calculation, the mode is simply 32. And that is how this goes. So, I mean, these examples have helped us to demonstrate how to calculate the mean, median, and mode for both ungrouped and grouped data. If this is new to you, you want to practice your hands on as many questions as possible so you can master it. I think the big deal is about the formulas and to know what the terms of the formulas represent for group data in particular. So with this, we'll come to the end of this video on measures of central tendency. Expect another measure in the next video. So if you have not subscribed, be sure to do that. And of course, hit the notification bell so you can always get alerted each time a new video is released. And do not forget to comment, like, and share so that more people can see these videos and learn. Thank you so much for being here. See you next time. Bye.